Hello, welcome to this video. In this video, we are going to discuss about how an ideal and practical regenerative Rankine cycle is performing, and we are also going to discuss about what is the meaning of regeneration in the simple Rankine cycle, and how the regeneration increases the performance of the Rankine cycle in overall. Okay, this is how a typical regenerative cycle works. To be frank, the complete process starts from the boiler, the heat addition process. The high temperature superheated steam which is coming out from the boiler is entered the turbine, and once it comes out from the turbine and enters a condenser where it get condensed, and then condensed water enters into the pump and it is pumped back to the boiler. Before it's pumped back to the boiler, the water comes from the pump is getting heated by the exhaust by the expanded gas from the turbine 1 and turbine 2, because of the input temperature of the feed water is increased before it's entered into the boiler. Since it has certain heat energy in the water before it enters into the boiler, the amount of heat required to add or increase the feed water into a superheated steam is decreases, so that the quantity of the heat supply decreases in if once the quality of or the quantity of the heat supply decreases, the overall efficiency of the Rankine cycle increases, because the heat supply comes and it's placed in the denominator part of the efficiency equation. So this is how that overall efficiency increases by the process of regeneration. You will get more clarity about this when we watch the video. Through that you can come to know about how exactly regeneration takes place with a PV as well as TS diagram. First watch that video and come back, and we will discuss about further with respect to regenerative heat cycle.
So arrangement consists of boiler. Through boiler we are supplying 1 kg of steam is given to the HP turbine. This one is entry as usual is 1, exit is 2. So this one is entry is 2, and from this exit is 3. So this one is also equals to 1 kg. Out of this 1 kg steam, some kg of steam extracted from this point. Let's call this is m kg steam. Naturally it is a fraction, because this one is 1 kg and m kg extracted, 0.2, 0.3 kg extracted. The remaining of the steam, which is equals to 1 minus m kg at same 0.3. So the enthalpy at all this point is same, only the mass is divided. This enters into LP turbine at state equals to 3 and expanded to state equals to 4. Mass is 1 minus m. And now we have here a condenser. So this one is low pressure, is high pressure. This job is taking place at intermediate pressure. I am getting here 1 m kg of steam which is extracted from this side, and from this I have, this one is 4, this one is 5. Is the mass is still equals to 1 minus m, but this time it's a water. Is it a low pressure water? This water and this steam, they are mixed up in one adiabatic chamber. This one is low pressure, intermediate pressure, this one is also intermediate pressure. So this one is also intermediate pressure, taking place at intermediate pressure. And then this goes to another pressure, another pump, and finally it goes to 1, which is a high pressure. So if we consider simple Rankine cycle, entry to boiler is 1. So this one is 1. 1 to 2 is constant pressure heating process. 1 to 2 is constant pressure heating process. And then 2 to 3 is expansion, and this one is 4. That is for simple Rankine cycle. Now I want to compare simple Rankine with regeneration now. So I will modify this point as simply as A. This one is A and this one is A. So just to distinguish all these points. So all these points are given as 1A, 4A, 3A, and point 2 I am keeping same. So let come from two sides. We fix up this point for both same point. To compare simple Rankine and regeneration, I keep this point is same. Now I am moving from this point, and is the expansion takes place up to point number 3. From 2 to 3, expansion takes place in. During this, is the mass is 1 kg. Is this process is takes place in HPT. At this point, do you have division of mass? So is the one mass is going to this side, and is the other mass is going to this side. The mass going on this side, is it equals to m? That is the amount of steam blade per kg of steam flowing in the circuit, and is 1 minus m is left, and this steam is it passed in the LP turbine, and expansion from this is takes place from 3 to 4. So expansion takes place from 3 to 4. During this one, mass is 1 minus m, and is this process takes place in LPT. In LPT, then we have a condenser. In condenser, is it a phase change process? So let me add some point here. This one is 4, this one is 7. Is 4 to 5 is a phase change process. So 4 to 5 is a phase change process. So 4 to 5 is a phase change process. So this point is overlap. Then is 5 to 6 is a compression process. And this point is this point. Am I correct? This one is 6. Now at 6 and 3, that is this point 6 and this point 3. What is the mass at this point? Is it 1 minus m kg? So during this one, is the mass is 1 minus m kg. So one branch is coming from this side and other branch is coming from this side. One branch is coming from this side, other branch is coming from this side, and you are getting a saturated water. So one branch is coming from this side, that is at 3, which is the mass equals to what? M. And this mass is coming equals to what? 1 minus m, which is that enthalpy equal to 6. So 6 is the water enthalpy and 3 is the steam enthalpy. So because of this one, will the temperature at the water will increase. And now at this point 7, is it enters into the boiler. So for our side, this one is point number 1. So if you compare this one, is the point number 2 is fixed for boiler. And in a simple Rankine cycle, is the entry to the boiler is 1A. 1A. And in case of regeneration, is the entry is 1. Is 2 minus 1 is less than 2 minus 1A. So is there is a reduction in heat transfer. If the reduction in heat transfer is there, we will claim directly that the efficiency will increase, because efficiency is given by W net divided by what? Q in. As far as W net is concerned, is it same quantity if I neglect the mass M. But in actual case, the W net in this case will be lower as compared to simple turbine, because when we consider simple turbine, we are moving from 2 to 4, and during that process mass is 1. Now same path is traveled, but one time the mass is 1, and for the remaining time the mass is less than 1. So naturally work developed in this case is less as compared to the simple Rankine. But where is the improvement? Improvement is on this side. Is this is a reduction in heat transfer or heat supply. Because of this one, your gain is this. This decreases, so this increases. So accordingly, if this is decreasing, what we claim is that is the mean temperature of heat addition has been increased. Now see, this one is 0.1 and this one is 2. If you try to find out the mean of these two value, and if you try to find out the mean of this one and 2, naturally for this 1 and 2, mean will move slightly higher, because this is the addition of two higher temperatures. and this is addition of what? To lower temperature. Yes. So in this case also, our claim is same, that the mean temperature increases.
Hope this video might have given more clarity about the regeneration process, which is taking care, which is taken in the regenerative vapor power cycle. Sorry, regenerative Rankine cycle. Okay. This is how a typical TS diagram for regenerative cycle looks alike. And the advantage of regenerative cycle over a simple Rankine cycle are the heating process in the boiler tends to become reversible. The thermal stresses set up in the boiler are minimized. This is due to the fact that temperature ranges in the boiler are reduced. The thermal efficiency is improved because the average temperature of the heat addition to the cycle is increased and the heat rate is reduced in the regenerative cycle. And apart from this, we can also see that the blade height is less due to the reduced amount of heat or reduced amount of steam passed through the low pressure stages. And sixth advantage is due to the many extraction, there is an improvement in the turbine drainage and it reduces erosion due to moisture. And finally, a small size of condenser is required to complete the process of the Rankine cycle. And the disadvantages are the plant becomes more complicated since there are a lot of pipes connected between the devices in and there, and it becomes like cumbersome when we look it from the bird's eye view of the plant. Because of the addition of heaters, greater maintenance is required, and for a given power, large capacity boiler is required. The heater are costly and the gain in thermal efficiency is not much in comparison to the heavier cost. These are all some of the disadvantage of adding reheater or regeneration process in the simple Rankine cycle. That's it. That's it, guys, for this video. We will meet in the next video. Till then, take care. Bye bye, and see you in the next video.